Welcome to the video lecture on signals and systems. We are discussing about operation on signals. This video we will discuss about signal multiplication. So how to perform multiplication of two different signals. Multiplication of two signals is nothing but multiplication of their corresponding amplitudes. So this we have to do just like how we have performed signal addition. This can be represented by a simple equation y of t is equal to x1 of t into x2 of t. So this equation is in case of a CT signal. In case of a DT signal, you will call it as y of n is equal to x1 of n into x2 of n. So let's see a good example to understand the concept. Now the point is just as same as how we have added two different DT signals. So the same way we will multiply two different DT signals. We are concerned only about the amplitude here. So if you can see here, x1 of n signal has different amplitude values as 2, 3, 5 and 1. x2 of n has the amplitude values as 3, 4, 2, 1. As you all know, x of 0 is 2, x of 1 is 3, x of 2 is 5, x of 3 is 1. Similarly for the second signal. So we will add both the we will multiply both the x of 0 values, both the x of 1 values, both the x of 2 values and x of 3 values. So what we will do here, y of n is equal to x1 of n into x2 of n. So multiply the corresponding values. 2 3s are 6, 3 4s are 12, 5 2s are 10, 1 1s are 1. So that's how you'll have to get multiplication of a DT signal. Let's check for the CT signal. So as you can see here, I have plotted two different signals called x1 of t and x2 of t. So we will multiply these two signals to get the final output signal in this way. So what we have to do, we have to keep in track of the signal interval, time intervals here. So I will conclude my time intervals as 0 to 1, 1 to 2, 2 to 3. So between 0 to 1, check out the amplitude values for both the signals. So between 0 to 1, x1 of t is 1, x2 of t is 1. So I will mark the same. Between the time interval 1 to 2, x1 of t value is 0.5, x2 of t value is 0.5. So I mark the same. Between the time interval 2 to 3, x1 of t value is 1.5 and x2 of t value is 0.25. So after charting down these amplitude values, what we have to do next is multiply these both amplitude values, get the answer and plot the signal and call it as your output graph. So between the time interval 0 to 1, the values are 1 and 1. So 1 multiplied by 1 will give you 1. So I plotted as 1. Between the time interval 1 to 2, the amplitude values are 0.5, 0.5. So 0.5 into 0.5 will give you 0.25. So between 1 to 2, I plotted 0.25. Between the time interval 2 to 3, the values are 1.5 multiplied by 0.25, which will be 0.375. So between 2 and 3, I have marked the same. So after you mark these amplitude values, make sure you track the corresponding shape accordingly. So that's how you will get a multiplied signal. So next, we will see about inverted signal in the same lecture. We have already seen about a reversal signal. So this is the other version of it. So in time reversal, or how did we actually get it? We folded the signal about y-axis, just like closing your notebook. So in inverted signal, what we'll have to do is, we will have to fold the respective signal along x-axis. So time reversal, we are folded about y-axis. So this inverted signal, we will fold it about x-axis and we will also call it as amplitude reversal. In very simple words, I could say that flip your signal upside down. So whenever the amplitude of a signal is multiplied by -1, then it is known as amplitude reversal. So here the signal will produce its mirror image about x-axis. So as I told you, you'll have to fold the signal about the x-axis. Just flip the signal upside down. So the equation of this is y of t is equal to minus x of t. In case of time reversal, it was x of minus t. But amplitude reversal, you should call it as minus x of t. I've shown you a CT signal example. The same you could apply for a DT signal too. So if you can see here, this is my original signal x of t. And this is my inverted signal x of minus t. Minus x of t. So what is the difference between these both? I've just folded the signal about x-axis. I flipped the signal upside down. So just draw the signal upside down and this will look like this. So the same concept you can apply for a DT signal, where the amplitude values you can just plot upside down. So that's all about operation on signals. We have discussed almost all the operations, all the important operations on signals. We have covered both CT signal and DT signal example. So this is your fourth assignment for this particular topic, operation on signals. Find the graph of the combined discrete functions. G of n is equal to u of n plus u of minus n. G of n is equal to u of n minus u of minus of n. So this is very simple. U of n is your unit step. So add your unit step with its reversal. Subtract your unit step from its reversal. So that's all for this video. In the next video, we will discuss more solved problems on operation of signals so that you will have a better understanding. Please complete the assignment within the stipulated time. See you all in the next video. Thank you.